Welcome to this video, where we will explore one of the most fascinating and mysterious concepts in quantum physics, superposition. Superposition is a phenomenon that allows quantum particles to exist in multiple states at the same time, defying the rules of classical physics. It is one of the foundational principles behind quantum computing, quantum communication, and many other emerging technologies. Today, we'll break down superposition in simple terms, explain how it works, and explore why it is so important. To understand superposition, let's first recall how the classical world behaves. In classical physics, an object has a definite state. A ball is either on the table or it is not. A light switch is either on or off. These states are mutually exclusive, and we can measure them without ambiguity. Everything in classical physics follows this clear and predictable pattern. Quantum particles, however, behave very differently. A particle such as an electron or a photon does not always have a single, definite state. Instead, it can exist in a combination of multiple states simultaneously. This combination is what we call superposition. Until the particle is measured or observed, it is not restricted to one state. Instead, it exists as a probability distribution of all possible states at once. To visualize this, imagine a spinning coin. While it is spinning in the air, it is neither heads nor tails. In a sense, it is both heads and tails at the same time. Only when the coin lands do we see a definite result. Similarly, a quantum particle in superposition holds multiple possibilities until a measurement forces it into one specific state. Superposition is not just a theoretical curiosity, it is a real and measurable property of quantum systems. Experiments with electrons, photons, and even larger molecules have demonstrated that particles can occupy multiple states simultaneously. In the famous double-slit experiment, particles sent through two slits create an interference pattern on a screen, a result that can only be explained if each particle passes through both slits at the same time. Existing in a superposition of paths, superposition is also at the heart of quantum computing. In classical computers, bits are either 0 or 1, so computations are performed one step at a time. Qubits, however, can exist in superposition, representing both 0 and 1 simultaneously. This allows quantum computers to perform many calculations at once, exponentially increasing their processing power for certain tasks. Superposition enables quantum computers to explore vast numbers of possibilities in parallel, something no classical computer can achieve. Entanglement and superposition often work together. When multiple qubits are entangled, their superpositions become linked, allowing complex calculations and correlations that classical systems cannot replicate. This is why superposition is not just an abstract idea, but a practical resource for quantum technologies. It is what allows quantum computers to perform tasks like factoring large numbers, simulating molecules, and optimizing complex systems with unprecedented speed. Despite its power, superposition is fragile. Quantum systems are extremely sensitive to their environment. Interactions with heat, light, or other particles can collapse the superposition, a process called decoherence. Maintaining superposition for long enough to perform useful computations is one of the major challenges in building practical quantum computers. Scientists use advanced techniques, such as superconducting circuits, trapped ions, and carefully controlled photons, to preserve superpositions and reduce the effects of noise and interference. Superposition also has profound philosophical implications. In the classical view, reality exists independently of observation. A ball on a table is on the table whether or not we look at it. In the quantum world, however, superposition suggests that observation plays an active role in shaping reality. Until a measurement is made, a particle's state is not definite, and reality itself is probabilistic. This challenges our intuitive understanding of the world and invites deep questions about the nature of existence. Causality and knowledge. In summary, superposition is a uniquely quantum phenomenon in which particles can exist in multiple states simultaneously. It defies classical intuition, enables quantum computers to perform parallel computations, and challenges our understanding of reality. Superposition, combined with entanglement and other quantum properties, forms the foundation of a new era of technology and scientific discovery. By understanding superposition, we gain insight into the strange, probabilistic, and interconnected world of quantum mechanics. It reminds us that the universe at its smallest scales is far more complex and astonishing than our everyday experience suggests. Superposition is not just a mystery, it is a window into the extraordinary possibilities of the quantum world. Thank you for joining this exploration of superposition. As we continue to study and harness this remarkable phenomenon, we come closer to unlocking the full potential of quantum technology and deepening our understanding of the universe.